Okay, first off, show of hands. Who wants the obligatory intro video? It's the graveyard session. Do you want a little video, or do you want to launch straight into the content? Video? Nah. Okay. Cape Town voted for the video, I'm just saying. Okay, we'll skip the video. No, yes, no. Okay, video. Come on, video. You must play now. It doesn't like going backwards. Let's go forwards. It's fun, I promise.
I start my days, sun rays, I tap the phone, coffee's on, I mow the lawn, impressing Sean, so connected, so effective, I let it drop, clean it up, heat and smart, I do my part, get in the car, superstar, they're watching me, IoT, I check my stock, what a shock, buy some prawn, my oven's on, coming home, future zone, all for me, IoT, live like a Bosch, with many connectivity solutions for a smarter future, from Bosch.
Pay, would you believe it or not? Anyway, that's got nothing to do with the talk. Okay, so guys, today what I'm going to try and teach you is what you see in front of you. I'm going to try and give you some tools. I've been at that home automation gig for a while now. It's become a little bit of an obsession. In my day job, I run the technology group. It's at Netstar, and we build massive amounts of IoT devices. It's a recent gig for me, but I'm really pretty passionate about IoT and home automation. And I'm going to try and teach you in 40 minutes kind of what I've learned in 2.5, 3 years of being at this. So my aim is to try and give you a bunch of tools so that if you're interested in this, you know where to start, you know where to go. But most of you are devs in this room, right? So I'm going to teach you functions, I'm going to teach you APIs, I'm going to teach you how to do this, and then hopefully you can use your imagination and see how this is applicable to your world. So it's going to be super demo-filled. Slides are minimal. But I just want to try and orientate you on sort of what I'm going to show you today. So in the box in front of me here, in my little Tupperware, I have 3 of these devices. They're called Sonoff Basics. They cost about 110 bucks. You can get them at lots of hobby electronic shops, online, Take-A-Lot, all over the place. They come with some nasty Chinese firmware on, which I'm going to show you how to blow away and put some nice open source stuff on. And in the diagram, you'll see switch 1, switch 2, and switch 3 over there. Those are my 3 Sonoff devices. They're each connected to one of these light globes over here. The first one has a switch on it that we're going to discuss. The second one has a temperature sensor on, and the third one has a motion sensor on. So I'm going to teach you a bunch of stuff, how to take not just control, but how to build sensors and put them into your devices. And then we're going to get through the rest of the stuff. We're going to show you how to use some voice control in this, and we're going to take a look at cameras and some other external control. At the bottom, I've got a whole bunch of server-side stuff. We're going to spend a lot of time in an app called Node-RED. If you haven't heard about it, I suggest you take a note of it. It's kind of like what a low-code, no-code environment does for the cloud, but it runs locally. And really, it's a fantastic IoT-based sort of visual programming environment. You're going to see it, don't worry. And then I run a whole bunch of other stuff in Docker, Home Assistant, InfluxDB, which we'll talk about, and DeepStack, which is an AI algorithm. So let's just start with Tasmota. Tasmota is the open source firmware that runs on top of these things. You know, if you get one of these things, don't be afraid to stick your finger in it and take it out. And oh my God, there's a circuit board inside. Inside that circuit board, kind of looks like this. What you want to do if you want to program them is go to your favorite electronic shop and buy something called an FTDI. It's basically a USB to serial converter. So it takes USB in one side and it takes serial out the other side. You'll see there'll be 4 pins at the end that come out of that. You don't even have to solder it. You can literally just take some jumper cables and stick them into that board. Stick them into the 3.3 volt, the RX, receive, the TX, transmit, and the ground rail. They're all well labeled on that FTDI. If it doesn't work the first time, swap the RX and the TX around, because sometimes receive goes into transmit and transmit goes into receive. So if it doesn't work the first time, you can't blow it up. Just don't put the 3.3 volt in the ground the wrong way around. Then you will blow it. Okay. But when you put it in there, you literally, it used to be a real mission to program these things in the old days. Right now, you just go to a website, the Tasmota website. You literally do it from the website. Once your FTDI is plugged in, You look for it on a serial port, and you can program your device straight from a website. And that blows away the nasty Chinese firmware and puts a nice open source stack on it. So it's really, really simple. It takes all of 3 seconds. I'm really short on time, so I'm not going to do it today. If you really want the bits and bytes on how to do it, look at my previous video from the previous DevConf. I spent about 15 minutes explaining how to program it. But now you can literally do it through a website. OK, so on switch number 1, as I mentioned, we're running this firmware. And what I did on switch number 1 is I connected a simple switch to it. So when you connect external peripherals to this little board, you have those 4 pins that you program it with, and you can now hook stuff up to it, right? So if you put one of these things in your light switch, they're small enough. In my house, I just took some insulation tape, wrapped these things in insulation tape, and stuck them behind the light switch. So every single light switch in my house has one of these things behind it. And then I wire the switch, just as I've showed you here, onto the switch on the board, so that when you walk into your room, you can still push the light switch and the lights go on and off, but you still have a little interesting controller that's on the Wi-Fi network in your light switch, right? So proviso number 1, if you want to do this, you need good Wi-Fi in your house, because if you've got crap Wi-Fi, your switches aren't going to work, your family's going to get upset. So it's a really good excuse to go to your wife and say, I need really good Wi-Fi in the house, right? You wire it up by connecting it to that receive port over there. You can actually connect it to the transmit port, so you can overload those ports. And then I'm going to show you now, once you've done that, how you go about configuring it. But before I jump into that, once you have the firmware on this device, it comes with a whole bunch of other stuff. It comes with a console, and I'll show that to you now. And it comes with an interesting rules-based algorithm that runs locally on the device. So you guys are all devs. You kind of understand if statements and do statements, right? So this thing has a little configurable rules engine that runs inside it. And how you make the switch in your house work like a normal switch is you write a little rule. I'll show you now how I configure it, but basically if that switch that I plugged in on those ports over there, that switch that I plugged in down there, I configured as button number 2. And now I write a little rule that if I push button number 2, state number 10 is if I push it and let it go, push it once and let it go. Then take the power 1 relay, which is the first little relay on this board. This thing only has 1 relay, so that's the switch that's on this board. And send command number 2 to it. That means toggle it. So that means if you push it once, it turns it on. If you push it again, it turns it off. So you can also say power 1, that will turn it on, and every time you push it, it'll turn the power on. People can get a bit irritated. Or you can put power 0, and it'll turn it off. But here's where it gets interesting. Now, you guys all understand how to use a smartphone, right? So a smartphone, you can only not just push the screen, you can push and hold, and you can double tap. So now because we have a smart device sitting behind our switch, we can start overloading our switch to do other things. We can say, well, what happens if I double tap the switch? And in this case, I'm writing a little rule to send a message on the MQTT bus. I'm going to come to MQTT just now, that says I've held it or I've double tapped the switch. Now, this gets really useful because now you have a switch in your house that doesn't just turn the light on and off, but I can double tap the switch to do something with it, or I can click and hold the switch to do something with it. So now you've taken a simple switch that only had 1 function, and you can teach it to do 3 different things. So let's go and have a look at that. Oops. OK, so here is a view of the web page on this device. So once you flash it with that firmware, and you join your wireless network, basically it presents a little web page, just like your router does or whatever you have on your home. So it's really, really cool, right? It's all configured via the browser. If I hit the configuration button and go to configuration, you can see all I've done on this device is I've said, I've got a button. The button comes in GPIO 3. That's that TX port that I showed you on the board. And I've called the button number 2. That's all I've done to configure this thing, right? And so now when I go back to the main menu, and I go to the console, just to see what's going on, and I click the little button. If I push it once, the light turns on. There's the toggle. And if I push it again, the light turns off. But I plunked that rule into this environment that I showed you just now, right? So let me quickly show you that. If I wanted to program the rule into this environment, I'm just going to grab that rule code quickly. I literally, in this console, all I do is I paste in the code that I showed you in the PowerPoint. So I can simply bang in that code over here, right? Rule 1, on button state, blah, 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 blah. And now I've turned on a rule that runs locally on this device. So this is, think about it as an edge rule that's running on this device. And so now, if I look on the bus, now I didn't explain this too well, so let me quickly jump back to the PowerPoint and show you this. PowerPoint. So if you look over here, the way these devices speak to the world is they sit on a Wi-Fi network, and they speak to a server called an MQTT server. If you just go and Google it, you'll kind of read a little bit about this. But basically what it is a pub-sub mechanism. So that runs a little server. All of these switches, these task motor switches, send a message to that MQTT server. So all the messaging that they send out, they're basically sending these little messages to the MQTT server. There's a protocol for it. It kind of works like a REST API. There's basically a slash algorithm that says, I'm sending a message on the bus. I'm going to show you one of them just now, right? The reason it's really cool is that you divorce your subscribers from your publishers, like any good bus, right? So basically, your clients over there are sending messages, and you can have subscribers here at the bottom that subscribe to those messages. So what I did when I wrote that rule is I said, when I double tap the button, publish a message on the bus that says double tap, and when I hold the button, publish a message on the bus that says hold, right? So that's pretty cool, because now I've got a thing that sends messages, but now I need to do something with those messages, right? So let's figure out what we do with those messages. To catch those messages, I'm going to use something called Node-RED. As I mentioned in the beginning, it's a web-based IoT environment that's a low-code visual programming environment. Instead of me ranting on about what it does, let me kind of show you what it does. Where is my console? That should be that, and that should be that, right. Okay, so we pop over to Node-RED over here, and I'll create a blank flow. And you can see, once it's loaded its flows, I get a whole bunch of tools on the side here. So the thing I want to do right now is I want to search for MQTT, and I want to create an MQTT subscriber. So I'm going to subscribe to any of those messages that come on that bus. If I look in the configuration for that, it'll ask me where is my MQTT server. It's really, really simple to stand up one of those. If you can either just install the binary on a Windows machine, you can apt-get it if you're on Linux, or if you're into Docker, you can just pull a Docker container with MQTT server on. So you need one of those in your house if you're going to do this type of stuff. But there's lots of ways to install it. It's a product called Mosquito. That's the big open source one. It's really simple to install. So I'm not going to go into the depths of installing it, but just understand that you need to have one of those. So I'm running it in a container on this environment. Right. So now let's subscribe to something. So I'm going to stick them in a debug node over here. I'm going to look for any of, and this is how you configure the Node-RED environment, right? You literally wire stuff together. So I'm going to, mouse. Man. Don't be confused that programming on stage is tough. Okay, I drew a line. I'm a hero. The one thing that you have to do, right, when you're working in MQTT is you have to subscribe to something. So as much as I configured this, I have to subscribe to a topic. And the topic, if you recall that I showed you in the rule, I was publishing the rules under DevConf hold devconf/double. So I'm going to subscribe to anything devconf /hash. So that's basically any message, hash is equivalent of star, right? So any message that starts with devconf, anything that comes after that, I'll subscribe to. And I'm going to choose the quality of service. Again, you can go read if you want a bit about this. The quality of service determines how many messages it sends. So it'll guarantee sending only one. It'll guarantee that it gives you an ACK when you send it, or QoS0 is basically fire and forget. You get what you get. So QoS0 is kind of the default one unless you really want guaranteed delivery. And let's make sure that we look at the whole message object when you do this. Okay, so I'm going to go ahead and deploy that. And now, if I double-click this, you'll see in the debug window, I've got a debug pop-up, and it says, I subscribe to a topic called switch 1 double, and the payload was 1, right? So they're at fired. And if I click and hold, you see I've got a message called hold on the bus now. So this little device over here is putting a message on the bus, and I'm subscribing to it. So you go, okay, so what? That's super interesting, but what? So what? So let's do something interesting with it, right? I'm going to put a switch statement in here. If I can program with my mouse, I'm going to drag the output of that into a switch statement. The switch statement, I'm going to say, well, if the message, remember, look at the debug load here. So the message comes in. The node is on topic. So we're not interested in payload. We're interested in topic. Okay. And if the topic is, let's copy that. Now let's copy the value. The topic is that. Then let's go out one node. If the topic is this, let's go out here. So basically what we've done is we've said, look at the topic. If the topic is double or if the topic is hold, create a switch. Now you see the switch now jumped. Now it's got two outputs, right? So you kind of see the low-code environment popping out now. Okay, so now I've got a way to take the thing and differentiate what it is. Now I'm going to drag in a little function. So if you don't have a node for what you want, you can always fall back to JavaScript. And I'm going to wire a function in here. And the whole idea with this function is that I'm going to create a little bit of code that sets up sending a message on the MQTT bus. Because as much as these guys subscribe or send messages on the bus, they also subscribe to the bus, right? And if you pop back to the actual configuration of the web page running on that thing, and you go to the information page, you will see that this guy subscribes to command switch 1. So if you want to send commands back to the switch, you send messages to CMD switch 1, okay? That's its address on the bus. So what I'm going to do over here is I'm going to set command, okay, and I'm going to send it to switch 2 this time just to be interesting. Power 1, that's the relay on that board, and I'm going to toggle it, just as I showed you previously, right? Okay. I'm going to copy this function. I'm going to paste it. I'm going to put it in here. I'm going to try and put it in here. And this one I'm going to change to switch 3. I've got 3 switches in this little plastic container over here, right? And then we're going to simply pop that message back out onto the MQTT bus. Only thing we have to configure is the quality of service that we want. We're going to go for 0 again, and we're going to deploy this. Okay, so now remember this. For those of you who can see it, if I push this button on the switch once, this one lights up, right? Switch number 1. If I push it again, switch 1 turns off. What's going to happen when I click and hold? Switch 2 lights up. All from the same button, right? If I click and hold again, and if I double tap, so look at the possibilities now. You've got one switch, and you'll switch 3 different lights on, all with one switch. But I don't have to just turn lights on and off, right? Because now I've got a message on a bus. You guys are devs, right? I could catch the double tap. I could do some other interesting stuff, right? Turn the alarm on and off, open the front gate, turn on the coffee machine. The possibilities are endless, right? All from a light switch in your house. It's kind of cool, right? Okay, back to slides. Okay, the second device has a temperature sensor in it. Temperature sensors kind of get interesting because how would you wire a temperature sensor into this board? Again, exactly the same board, exactly the same pins. Now, one of the most common temperature sensors on the market is called a DS1820B. Remember that if you go to the electronics shop and ask for them. I'll send you some links at the end if you want to buy these things. They cost about $20 if you buy just the chip, probably less than that. You can buy them in these fancy waterproofed cables, then they cost about $50 each. I have like 3 of them in my pool. They've been in the pool for 3 years. They don't rust. They last forever. They're unbelievable, right? You wire it into the board like this. You put the power on the 3.3 volt rail. You put the black wire on the ground rail. And then you put the yellow wire that comes on it onto the RX line, and you have to put a small little receiver, a 4K7 receiver. So this time you maybe have to solder. You can probably wind it around the pins if you're really scared of soldering, but don't be scared of soldering. It's cool. And then you can get temperature, right? So let's go and take a look at that. Oh, before I jump to the demo, the other thing I'm going to show you in the next demo is something called a time series database, right? So often, and the reason I chose to show you this here is that often when you're storing large amounts of data, if you're going to be storing large amounts of temperature data, weather data, you want some place to put it, right? Most people kind of go to SQL Server because that's there, or some type of relational database because that's what they do in their day jobs. Just be aware there's the whole world of databases out there called time series databases, right? And what they're designed to do is work with the x-axis being time. So in a relation database, you get to design the table you want. You can choose rows and columns just like you would. You can create primary keys. But they're really terrible at storing huge, huge volumes of time series database, right? Go and Google something called InfluxDB. There's actually a couple of them. but Influx is probably the most popular one on the, right now. Again, a really interesting open source project. It can store millions of entries a second, even in a Docker container image, and it's really, really efficient at both the query side and the storage side. I've been storing probably 2.5 years of data at 20-second intervals, and my database is less than 500 meg, right? And I can query that data in a couple of seconds on an old Mac machine lying in the cupboard. It's super efficient. So go and take a look at that. I'm going to show you kind of how to wire that up now. Okay, back to the demo. So let's take a look at the temperature sensor. Temperature sensor is connected to switch number 2. If I pop back to the same configuration page that I showed you just now, the only difference now is when I go to configure the module is in the GPIO3 port, I have a DX1820X. And the reason I write X in there is that those things are actually pretty amazing. You can chain them. So you can have multiple temperature sensors all on the same bus. You could have 3 or 4 of them. And they'll all pop in as different temperature sensors. So if you want multiple temperature sensors hanging out of your light switch because you want to know the temperature, I don't know, all over your bedroom, I won't ask, you can do that. This time it's kind of nice because you don't have to do any fancy rule stuff. You'll see now as soon as I configure that, the web page shows me what the ambient temperature is. Yeah, it's showing you the temperature of the temperature sensor. If I hold it in for a while, it takes way too long, but you'll probably see it kind of come up over time. There we go, 22.2. You can see it starting to rise. If I go to the console now, on this device, you'll see that it's spewing out the state of the temperature, guess, on the MQTT bus all the time now. So now I'm spewing out of this device, I'm spewing tele switch to sensor, and you can see the temperature's buried in there somewhere, right? Right, if we pop back to Node-RED, I'm again subscribed to messages on the bus. Now I'm subscribing to tele switch to sensor, right? So I'm subscribing to all of those messages that are coming off that little device and spewing out the temperature. You noticed that what was spewing out a JSON object. I don't know if you noticed that when I showed you that. So here, I'm telling it to parse the output of this subscription as a JSON object, which is pretty nice because now if I show you what's coming out of that sensor, and I clear this debug log over here, you'll see I'm actually getting a JSON object parsed out of here. Ooh, my battery's going flat. That's not a good idea. With the temperature. So you can see DS1820B is here, and you can see the temperature is 23 point something, okay? I'm writing a very small function to basically take that JSON object, unpack that whole payload, and simply write the actual absolute value of the temperature back into the payload. So I'm replacing the payload with that big JSON object simply with the numeric value. And the reason I'm doing that is because I want to write it to an InfluxDB database. The amazing thing about Node-RED is it has this palette capability. So if you look at the palette, you'll see that there's hundreds of plugins. It's like its app store, right? And there's plugins for all kinds of devices, all kinds of databases, all kinds of environments. So if you're looking to speak to something, you probably don't have to go and write the REST call yourself. It's got a web API, so you can call REST natively, but you'll probably find a palette option, another one of these little boxes, natively in the environment. And it has one for Influx. And the way you configure the Influx one is you configure the organization, the bucket, and the measurement. It's kind of like the database, the table, and the value in SQL world. And then you just bang the value straight into it, and it logs it to the database. So if I pop over to Influx over here, you'll see that I've got an organization. I've got a filter that's on the measurement, and here's the value. And if I run my query, you'll see I'm getting my temperature, and you see how fast that was, right? And that's logged every 15 seconds. But like I said, it runs almost as quick when I parse a year's worth of data. And the database is super clever because it's time series, it'll actually truncate the value. If you ask for a year's worth of data, it'll give it to you in day values, as opposed to giving it to you, every second in a year. So it's optimized for giving you coherent data over the time span that you query against. Right. Back. Let me just check what my battery life is like. Oopsie daisy. This is not good. Give me a second. Because if I don't fix this, we ain't going to be doing any more presentation. Why is this? I hate 2-point plugs. Sorry, guys. Ah, 2-prong plugs are the bane of my life, I tell you. Right, let's pull Alexa out. We'll get her back just now. It's more important the PC stays alive. Right. Let's pop back to the PowerPoint. Right, switch number 3. Switch number 3 has got a motion sensor on, right? So the other thing that gets interesting is we all kind of have alarms in our houses. And we all have these PIRs sitting all over, right? But they're kind of these islanded environments. Very few people are able to integrate to the alarms. It is doable. We can talk about that in the break, but there's much easier ways to do it, right? So if you want to have a PIR sensor, again, kind of starting to look familiar, you can go to the electronics shop and you can buy one of those little PIR sensors. They cost about 20 Rand each. And you can literally wire it into your favorite switch again, right? The way you wire it in is it's just a switch. It needs power, so it needs ground and 3.3 volts. And the actual switch output goes into that RX port. So it's kind of like the toggle switch. I just had an extra wire because I needed to provide the little PIR with power. So let's jump back to the demos. So if we go to switch number 3 now, you'll see that switch number 3 has a little PIR in it. And if I wave my hand in front of it, can you see that it's gone from on to off, from on to off? The way I did that was I wrote a rule again. I'm not going to show you the rule. It was on the PowerPoint when you look at the slides. But basically all I did was saying, if switch number 1 goes on, put a message on the bus that says, what is it, stat PIR3, PIR1, and when it goes off, put PIR1 off. You kind of seen the same pattern as I did with the switch, right? So now instead of a switch being it's been a little PIR input. So basically I have motion detection. So what can we do with that? So now, you're kind of getting the flavor of the recipe here. I'm subscribing to stat switch PIR1. That was the message that was getting put on the bus. I'm going to wire it into this switch statement. Again, you've kind of seen this before. If the payload says on, then do that. If the payload says off, do that. You've kind of seen this before. And let's delete all of this other stuff, and let's deploy this. And now, if I move, I turn on switch number 3. But did you see what happened there, right? What I did was I fed it into a timer. And this timer counts down for X amount of time. And as soon as that timer runs out, I feed it into a second function, and that turns the power off. So now you can have a sensor in your room. As soon as you walk into the room, the light turns on. You can have a configurable amount of time, no movement, the light turns off. So that's how you build those cool sensors that you have in offices when you walk in. That gives you a self-turning on, turning off light. And of course, depending on the person in the room, you can kind of, the amount of time is now super configurable. If I want this to be 1 hour, I just change it to 1 hour, and I'll deploy that. And now next time I create the PR, you can see it'll count down for an hour before it turns the light off. You kind of get the idea. Toolbox starting to fill out, you're kind of getting ideas. Cool. Okay. So we've kind of done the what happens inside the house story, right? Now let's talk about what happens when you want to get to your devices and you're not in your home environment. Sure, all of you have heard of Telegram. If you haven't, go and read about it. It's my best alternative to WhatsApp. We don't like Facebook. We like Telegram. The really cool thing besides that is that Telegram offers a free bot interface. So that basically allows you, for free, to go and create a persona, an instance of Telegram that you control programmatically. And you can basically then create a bot and give that to your smart device or your smart home, right? So what we're going to do is we're going to wire Telegram into our Node-RED environment, and then we're going to start controlling our devices through the Telegram interface. And that, again, because Telegram is mobile and you can use it wherever you are in the world, you don't have to be on your home network. It reads you a really nice way to get back into your smart devices without having to punch a hole through your firewall or do any of that nasty stuff. So let's go and take a look. So in this demo, all I do is I went to the palette, and Node-RED has a palette for Telegram. There's actually quite a few of them, but it has a really nice one called Telegram Native. And all I have to do is configure my bot and give my bot instance. If I click this button, I'm going to click it right now because this one's being recorded. So my super secret key is sitting behind there. When you create your Telegram bot you go to the bot folder in Telegram and you tell it to create a Telegram bot for you. That's the bot in Telegram that controls your account, and he gives you this super secret key that you plug in here, and that basically authenticates you to Telegram as your bot. Once you do that, you put in the name of your bot, and hey presto, anything you send to your Telegram bot comes spewing out in your Node-RED environment. So if I pop over to Telegram and I tell Telegram hi, or H1 in my case, you'll see I'll have a message here somewhere, and you'll see that the message, if I look at the payload, says hi. So what can we do with that? Anybody guess? You're kind of getting the recipe now, right? You can put in a switch statement. I can say, well, if I say switch 1, or if I say switch 2, or if I say pick, go into 3 different ones, you can guess what switch 1's going to do, right? Okay, so let's try that. Let's turn off switch number 3 quickly. It's kind of blocking our view here. So let's pop. Now I remember why I disabled it. Let's do this. Motion detectors. Okay, back to Telegram. So let's go back to Telegram. Let's turn switch 3 off again. And let's say switch 1. And switch 1 turns on. And switch 2. Switch 1 again. Toggle. Switch 2. So you could be anywhere in the world. You could open your front gate. You could turn your lights on, turn your coffee machine on, all from the comfort of your phone. But those that were fastidious over there would have noticed that I had this other little thing in here. So what is this thing, right? So let's just bump back to the PowerPoint quickly. So we kind of did that. Now what I want to do is say, well, the other thing that most people have in their homes is cameras, right? Whether you have off-the-shelf ones, Wi-Fi cameras are becoming super prevalent, and I chose to use this little Wise cam over here. It's a cheap and nasty RTSP camera. RTSP is the protocol that they use to kind of send video over Wi-Fi connections. As luck would have it, we can grab those frames from the camera, right? So I'm going to flip back to the demo quickly. But in this case, Node-RED actually doesn't have a way to grab the frames. So what I had to do was I had to write a little command line command using FFmpeg, which is another free off-the-shelf utility that does really cool stuff with video. But I can just bang in a command line utility in Node-RED, and I can grab that PNG frame from the camera. So now, if I step up to my camera, let's just do this, and I type pick in here, and I look nicely at my camera, it's hopefully going to grab an image from the image stream. It takes a little while for the command to run. It's going to grab it and send it back to me over my Telegram interface. So imagine you've got a camera in your house, you're anywhere in the world, you want to see what's happening in your front garden, you send a message to your thing, boom, and you grab an image. Kind of cool, right? Okay, so what else can we do with this stuff? Well, it wouldn't be a Dev Days demo if we didn't do something with AI, right? I have to try and keep up with Jaden. So that got me thinking. So what Node-RED has is a plugin to something called DeepStack. DeepStack, if you haven't heard about it, is an image recognition kind of off-the-shelf Docker container. It does really, really cool stuff, object recognition, face recognition, and all of that good stuff, right? So I thought, okay, let's get interesting now, right? So what I've done is I've wired up this thing to take a frame of me, push it into DeepStack, do image recognition. If it sees me, to send a message on a Telegram bot and turn on a light. So let's give it a go. If I stare nicely at the camera, hopefully it looks at me, decides that it likes me, and it said, turned on the light because it recognized it was me, and it should hopefully have sent a message on the Telegram note to say, hey, Cliff, I see you, and it turned on the front light. So imagine you walk up to your front door, you push a button, it recognizes it's you, it opens the door, turns on the light, and says hello to you politely. Kind of cool, right? Yeah, you can clap. Okay, and for this last demo, because I think I've got 5 minutes left, I might need to get my Alexa back and ditch my laptop's battery, but let's do that quickly. For my last demo, what I'm going to show you is kind of the last bit of the equation, and that's how to get voice control into this puppy. Alexa, wake up. Good. So let's jump back to the slides for a second. Kind of work through the deep stack thing. We did that. Yeah, and that's kind of the last bit, right? So we've done vision, we've done kind of touch, we've done sensing. The last thing that everybody asks is, can I speak to my smart home, right? And the reason I use Amazon or use the Alexa environment, and I'll show you the demo now, is that Alexa's got a really cool feature in it. It's kind of a hack. When they first released Alexa, they did a deal with Philips. And they called it the Hue Bridge, because Philips and Amazon did a deal together where they wanted to control the Philips smart lighting. And basically, the real cool thing about it is that it goes to the cloud to do voice recognition, but all of the actuation, so the actual API calls, happen locally on the local network, because they assumed that you'd have something called a Hue Bridge on your local network. And so this device actually sends a REST command to the Hue Bridge to tell it what it's heard. And what Node-RED has done is they've written, well, one of the developers of the palette of Node-RED has written a little emulator to emulate a Hue Bridge and then take the voice commands and give it to you in the Node-RED palette, as I've showed you with all of the other stuff. So effectively, what I'm going to show you is basically how to create your own voice control with your own catchphrases, well, not your own catchphrases, your own statements, but you can catch it in Node-RED. So let's go and take a look at that. So it's super simple. All you do is you drag the Alexa Hub icon onto the desktop. You don't have to configure it or anything. You just literally drag it on, and then you drag these catchphrases on. And really, the name is what it does, is what the Alexa command will be. So in this case, what it's going to look for is the statement switch 1, switch 2, and switch 3. And now the function looks a little different, because basically what comes out is what you're telling the switch to do. Because it's emulating a light bulb, you can either tell it to turn on, turn off, or set its brightness to a certain value. So you can use those 3 trigger points. So if you look at the function I have here, I'm saying if the payload is turned on or true, do this. I'm turning switch number 1 on. Or if it's off or false, turn switch number 1 off. So watch this. Alexa, turn on switch 1. Alexa, turn on switch 2. Alexa, turn off switch 2. Oh, good girl. Alexa, good girl. She says something, I think. But again, the possibilities are endless. I'm showing you what you can do with a light, right? But you could tell it, I'm going to bed, or turn on something, right? And it can be a whole series of automations you can do. You can wire a whole bunch of stuff. So we use this, right? We have, my daughter loves it. We call it the dinner lighting. Turns off all the kitchen lights, turns on the light over the dinner table, turns the music. I mean, you can go crazy, right? But effectively, you've got a way to provide voice commands to something, catch it in a programming environment, and then your imagination can go wild. It doesn't have to be light switches, and that's the difference between this and the Philips Hue Bridge, where you could only literally control lights, right? Now you can do freaking anything with it. So, I think I'm almost out of time. I hope I gave you a whirlwind tour. I've kind of tried to compress everything I've learned, like I said, in 2 years into 40 minutes. But I've showed you vision, I've showed you sound, I've showed you temperature, I've showed you cameras, and I've showed you how to hopefully make and start the journey of building your own smart home and your smart life. Thanks very much, everybody. 2 minutes for questions.
Would you recommend running? Sorry, so sorry. Can you please just step up to the WITS University? Sorry, Cliff. Would you recommend running, for example, all of that software on something like a Pi, just to reduce having servers and stuff in the house?
Good question. So I would say if you've got a Pi 4, go ahead. My recommendation, if you do it on a Pi, use the external SSD boot capability. So just go and read up. You can boot a Pi from an SSD. Don't do it on the SD cards, because when you're doing this, there's a lot of read and write, and you kill the SD cards in about a year, and then all your fancy setup just goes to naught unless you back it up. So I learned that lesson the hard way. So yeah, Pi 4s are good. If you Pi 3, maybe, depends on how many automations you have. Otherwise, get yourself something like an Intel NUC or something like that that's really power efficient. Those work really well as well. I repurposed a really old Mac Mini, like a really old one, like an i3, that I put an SSD in, 4 meg of RAM, and I run everything on Linux with a set of Docker containers. works perfectly. It's been running for 2 years without sneezing. Yep.
Can I do the same thing with an Arduino, or is it just Raspberry Pi?
So Arduino, yeah, so Arduino is interesting. So you can treat an Arduino as one of these, right? But you best be careful, because as soon as you be careful how you connect to it. That's why I like these ESP, they call them ESP8266s. So any of these sort of smart devices that work over Wi-Fi are much more convenient, right? Because then you can literally power them and put them anywhere in your house. With Arduinos, you normally have to have some type of connection to it. You need to have a serial connection. So then you just end up pulling wires around to control your stuff. And then you kind of lose, it becomes, yeah, you spend more time doing electrical than you do control, and that becomes. So these guys, Sonoff make these things. Like I said, they're about $110. There's another company called, it'll come to me now, Shelly, yeah. So the Shelly ones are also quite nice, that are also programmable. Or you can buy a device, if you go to the electronics store, called an ESP8266. They sell little boards like this. They come with a USB port on it. You can program them. But they only work on 5 volts over USB. But then you can build your own stuff, right? So if you want to build a really fancy thing, like I built an entire irrigation system with that, right? And I made a little 5-volt power supply, plugged it in. But then you have like 10 outputs if you want. So if you want to control a lot of things, then you can put one of those devices in. So look for something called an ESP8266 if you want a dev board, a Sonoff if you want to program just these, or a Shelly, and look for something that's always based on the ESP8266, because they're all based on the one Chinese chip called an ESP8266. They're just different boards around that thing. So Arduino's slightly different. Yeah, another question.
So just to add to that, the ESP32 is just a little bit more powerful and has
Yeah.
Bluetooth as well.
Yeah, spot on. Yeah.
Just a question on that as well, because I do a little bit of IoT stuff myself. How have you found using so many Wi-Fi devices in your house? Have you had like Wi-Fi network collapse? Have you thought about using Z-Wave or Zigbee as an alternative network? Just a couple questions.
Good question. Really good question. So what happens with lots of people is if you don't have great Wi-Fi, your router eventually falls over. So I have, I think, 82 Wi-Fi connected devices. I have a Ubiquiti network. So I bought a decent set of networks, and so what you really want to start doing is if you don't want to spend too much money on building too much Wi-Fi stuff, then you just think about where your DNS server is and the stuff that's dishing out the IP address. So we're getting a bit techie now. But normally what happens is your DNS server falls over because there's too many devices on your network. So you can export that to a Raspberry Pi, for instance, if you don't want to go. Otherwise, most of the good mesh networks, most of the TP-Link stuff, or the Ubiquiti stuff is excellent if you really are going to go big time into this. But you're right. If I run it on, I did run it on a D-Link router, and when I got to 30 or 40 devices, the thing it just wouldn't give new IP addresses on the network. Not designed to handle so many devices. You're absolutely right. There are other protocols, so you can use other protocols. Zigbee or Z-Wave basically lets you put a gateway in your house, so then you have one Wi-Fi connected device, and then they use their own wireless frequency to speak to each other. That is another way of doing it. Lots of people do that, and then it depends. You get Zigbee and Z-Wave sensors, so then you don't have to worry about these things. They speak on that bus. So there is lots of ways to do it. So it's a really good point. My personal recommendation is if you want to do this, take the investment, build yourself a good Wi-Fi system in your house. It helps you with this, and it helps you with everybody in the family. You get great Wi-Fi in the house. So that's kind of the prerequisite. Like I said, you get an excuse to sell good Wi-Fi to the family. Okay, I don't want to steal Jade's time. I'm going to get off the stage so Jade can set up, but if you have more questions, come speak to me off the stage. Thanks, guys.